I can hear you.
Hello?
I can
All
hear you.
right. Can you see my screen?
Yes, I can.
All right. Hopefully everybody else can see my screen out there, and I apologize being for a couple minutes late, but having some technical issues here. So anyhow, just kind of wanted to share some information with you on this here webinar. We are doing the distance module today, and my name is Tim Walker, and I'll be the one hosting and moderating today. And I guess if I would, there's my email address on the screen. Hopefully you can see it. And then below that would be my phone number. So if you have any questions, feel free to contact me and or send me an email, and I'll be happy to help you out with any questions you might have.
Okay.
And so with that, I'm going to go ahead and get started. This will probably be maybe a little bit over an hour for the whole webinar, maybe a little bit longer, just depends on how long it takes us to get through it today. And I'll stop periodically and ask questions. If you guys have a questions, just raise your hand on the right and I'll be happy to entertain any questions. Right now I've got pretty much everybody muted, just to kind of keep out some of the background noise while I'm doing my presentation. And it just makes it easy for all of us to hear out there. So anyhow, again, just real quick, my name's Tim Walker, and we're going to talk about the distance module today. So if you guys are familiar with Test Universe, under Test Universe, this is the startup screen that we have, and off to the left is the different test modules that we do have. And the one that we're looking at is distance. And OMICRON does have two different versions of the distance module. One is just a basic distance module, and the other one is an advanced distance. The biggest difference between the two is the distance module only allows you to do like just different points on there that you want to test, whereas the advanced distance allows us to do a little bit more information out there that as far as doing some searches and stuff like that. So also just wanted to let you know that we will be recording this today. So hopefully you can go back and review this meeting later on. So under the distance module, I'm just going to go into the advanced distance, and I'll just kind of tell you some, as we go along, some of the different features that we've got in this module. And so if everybody's not familiar with it, OMICRON has this acronym that we borrow off of George Simon Ohm. It's called Ohm's Law by Ohm's Law by OMICRON. And so on that, the O actually stands for our object file. The H stands for the hardware configuration, and the M actually stands for the module itself. And the module that we're talking about, in this case here, would be the distance module. And so with that being said, the first thing you really want to do is take a look at your distance module, or your test object. And so when I click on test object, you'll see under the Rio function something called distance. And if I double click on the distance, it'll bring up this window. And under it, we can go and put up in our settings that we want to use for testing out the distance function. So the first thing it's going to do is ask you for the line length, and the line length is actually going to be defined in the impedance that you have. If you've got a relay, you can go in and look at the positive sequence value on it, and that's the value that we're looking here for our line length. And so just to make things simple for today, I am going to go in and just make this a 10 ohm line, and I will make my line angle at 85 degrees, and then you would basically select where your PT is connected, whether your PT is connected on the line side of the breaker or whether your PT is actually connected on the bus side of it. And so there is a drop down box that allows you to pick and choose which one you want. And then we also have the CT star point, and basically that's where everything is connected together on your neutral part. And so it can either be directions on the line or towards the bus bar. And so in our case here, we're actually going to be looking at the line. And then down here, you can put in some different tolerances if you want something better than 5% or different than 5%. So you've got your time, and you can also do an absolute value in milliseconds. And then we also have an absolute value for your impedance values down there at the bottom. And then down at the bottom, there is this thing called the grounding factor. And on our grounding factor, we have a case of L function. And in that, you can select your magnitude and angle, and pretty much that is going to be the value that you would pull out of your relay, because there's usually a K factor in there. But there are some different modes there because not all relays do the same thing. You can basically do a R sub V over R sub L, or an X sub V over X and L, which basically is going to be the values that some relays may use. Or you can actually use the impedance values off of that one. So in this case here, I'm just going to use a case of L, and I'm just going to leave this as my defaults. And then the next thing that we would look at was come up here, this other tab called my zone settings. And on zone settings, I can open this up. And now what we want to do is we want to go through and create our zones that we have for the specific relay that we're working for. So the first thing I would do is go in and create a new zone, and it basically starts out with zone 1, and it's got a label there, and this is going to be a tripping zone. And if I want, I can click on this and change it from a tripping zone to a starting zone or a non-tripping zone. But this one here, we're going to make it zone 1 as a tripping zone, which is kind of the standard function for a distance relay for a zone 1. And then the rest of this stuff would be pretty much the default as the top here. Now I can come down here under my zone details for zone 1. I can put in a trip time, and typically on a zone 1, you're going to get a 0 because you want an instantaneous trip. And then my tolerances and all that are pretty much, you can leave those at default if you want. Now, when you notice I created a new one, this whole line was black, which kind of, in a way, I think most people interpret that as being selected, but keep in mind that you've got to click that line if you want to actually edit this specific zone here. So if I come up and hit edit button now, it brings up a window, and then here I can select my different values that I want to set up for my zone 1 configuration. So I'm going to select a predefined shape of a Mohs circle. And on this Mohs circle, I'm going to set this up to be 90% of my line. So I'll make this as a 9 ohm forward reach on that. And if you want, you can do an offset Moh here, but I'm going to leave it mine at 0. And my angle is going to be 85 degrees. This came from the previous screen where I changed my line angle in there. And so I'm just going to leave this as the standard fault here. We can also come up here and we can use a lens type shape if we want, or we can also do a polygon type of a shape here and go through and create that in our test. So once I'm okay with this one, I'm going to have a reach of 9 ohms, offset of 0 degrees and 85 angles. And I'm okay with this. I'll say okay. And now you'll see that the picture comes up, and this is the actual zone 1 reach and my settings for that. Now, if I want to come and add another zone, such as a zone 2, As I said earlier, it looks black like I've actually got it selected, but I'm not. Zone 2 may have, I don't know, a 30 cycle delay. And so this one here, I'm just going to set it as a half a second. And now I can come up here and edit this one. And so I'd have to select this so it just looks like it's white, but I've actually got it checked here in this second box. I do an edit on this one. I'm going to add me another Mohs circle. This time I'm going to reach about 125% of the line, or I'm going to make this 12.5 ohms and keep my angle the same, and my offset is going to stay the same also there at 0. So now you can see I've got 2 zones, and I can come in and reach or add another zones for a zone 3. And this one here would be like a 1 second time delay. And then if I click on this one, I can come up and edit this one also. And I'm just going to make this as a Mohs circle. And I'll just say that this is just twice of what I've got on my pickup for the other one. So now you see all 3 zones. If I want, I can add a zone 4. My zone 4 is not going to be a tripping zone. It's actually just going to be a non-tripping zone, or if you're using it to start carry, you could use it for a starting zone. No time delay in this one. And so if I come in and edit this, and it's going to be a Mohs circle too, and let's just say that my forward reach on this one is going to be 15 degrees. But now I want this to be in actually a reverse direction. Here I'm going to set this up as 165 degrees. Actually, it should be 180 degrees plus 80 is going to be 265 degrees because I can't add today. And so now you actually see that this is my reverse looking zone that I've got out here. Once I'm satisfied with all 4 of my zones, or however many zones you're using in your case, I can come down here and say OK. And it's going to kick me back into my test object. And I would say OK here. And now you can see everything's been transferred into my distance module here for me. Also note reach here. This is just a line that's been across here, so I can see zone 1 is actually less than my reach for that transmission line. Zone 2 is overreaching, and zone 3 is going to be even further out, and then zone 4 is going to be a reverse looking zone, as we showed you earlier. And that pretty much sets up everything here. And so if I was going back and looking at my zones, or the 2 different modules that I was mentioning earlier was basically an advanced distance and a distance module. The advanced distance pretty much has the advantage of doing a search test, whereas just a regular distance module only allows me to do a shot. And so what that allows me is to come in here and place different shots. And they're just going to be different points that I can place on the diagram off to the right and actually be able to do like certain tests within that one. So with that one being said, I can either manually come in and add a test point. So if I wanted to do a test point at 0 degrees at an angle of 75, I could do that one. And let's just say I wanted a reach of maybe, I don't know, 50% of the line, maybe 5 ohms. And so you can see out here that's placed a dot. That's where it's going to place it, but I want to actually follow my maximum torque angle, so I can change this to 85 degrees. And now you can see that's on my maximum torque angle there at 5 ohms, which is basically halfway between that and my reach value there. And then by putting these values in here, you can either put them in magnitude and a phase angle, or if you want, you can put them in R and X values. And either way, it's going to calculate the other one for you. And so right here, you can see that it's set up at 55% of my line length. And I can change this and use this to actually add some other things that we'll go over here in a second. So if I wanted to test my point here at 5 ohms, I would come in and hit add at the top. And it's now going to add that to my table here down below. If I wanted to change that, I could change that to, let's just say 85% of the line. And now I can come in and add this one. And so just by doing this one at the bottom here, I can, specify how far out on the line I actually want it to be. So there's a couple different ways of adding points to this table. And then I can come in and select, the other thing too is I can select what kind of a fault type I want. So if I wanted a fault type of line 1 to ground, line 2 to ground, or line 3 to ground, or line to line, or phase to phase values, so it's either A to B or L1 to L2. It just depends on how you have your setup here. Or you can actually do a 3-phase fault here, and just depends on which one you want to select. So right now, these first two are set up as line to ground faults. And down at the bottom, what you'll see is you'll actually see a different tabs here. And by selecting these different tabs, we can put faults in here for the different fault modes that I actually want to simulate. So right now, we're only using phase 1 to ground, and that's kind of grayed out. And if I click on that tab, you'll see that I got values in here. If I want to come and do a phase-to-phase fault, I can come in and let's just say I wanted to do it at, I don't know, maybe 105% of the line. I can now come up and hit add. And now this is going to add this one to my phase 1 to phase 2 tab there. And so with all these things, you can have different stuff that you want to look at as far as the different phase to ground things going on as far as my test is concerned. So that's pretty much anything under a shot test. And really all I'm doing is actually adding a point anywhere on this phasor diagram or this impedance view that I want. If I come in and if I click on my impedance view, anywhere I click on my impedance view, it's going to select that as a point. And so I can basically add this shot at 6.24 ohms with a phase angle of 110 degrees. So if I hit add, it's going to come over and add this based upon what fault type I've got set. And then I can just make clicks anywhere I want and add shots. And so here again, it's almost kind of like adding dartboards and different configurations out there that we want to do. And that takes care of my shot test. One thing that I did fail to mention is if I come back into my test object and under my device, under the device part, you can actually put in information that is pertaining to the test that you're running. So you can put the name, description if you want, the manufacturer of your relay. You can put the device type, such as maybe an IEEE number or an ANSI standard number. You can put the address, serial numbers if it's a digital relay, and then additional information for 1 and 2. Allows me to put any other information. These are kind of free to be used in any way that you want. Moving down, I've got the substation name, the address, and then you can also put in there the bay name and information that all pertains to your substation in this device, or what the device under test that you're actually testing. Down at the bottom, you can select a high, low, or custom value for overload sensitivity. And so basically the default is high, and that's pretty much good for any kind of a digital relay. And then on the right-hand side, we are allowed to put in our nominal values for our test that's going on. So number of phases, typically it's going to be a 3-phase system, unless you've got a 2-phase out there. So that should be your default that comes up. I'm using 60 hertz here because I'm here in the US. But you could select 50 hertz here. And then here I would put in my V nominal, and this would be my secondary values. So if I am using line to line, I can put 120 in there. And let's just say that you were using 115 just to show you what goes on. Is if I put that in here, it's automatically going to calculate the line to neutral value for me here. And vice versa. If I come in here and put this at 69 for my line to neutral value, it would calculate my phase-to-phase value for me. And then moving down a little bit under V primary, this is where I would put my primary voltage. And so if it was a 138 kV system that I was working on, I'd make sure that I've got a K, and that's going to make it out as 138. And then it's going to go in and calculate my line to neutral values for me. And then the next section here, the next section is for my currents. And so typically most relays may use 5 amps as my secondary value that feeds into a relay, but you may have a system that uses only a 1 amp. So I would put my 1 amp or 5 amp in here. And down here for my primary, I can set this up as my primary current value, so my CT ratio. So if I had 1,000 for my primary current, I would set up a CT ratio of 200 to 1, or 1,000 amps to 5 amps here. Down under my residual voltage, these current factors, V line divided by secondary is going to be basically the square root of 3, which gives me 1.732. And then my I nominal over IN over my I nom is going to be 1, because it's just a factor of 1, and just kind of leave that there. And then down here I can come in and I can change my values for my limits. Maybe there are going to be cases where I want to limit my voltage and my current. Maybe we don't want to hold 50 amps on there continuous for that. And so what I would do is change that to maybe something lower, so we basically eliminate the factors of keeping that on for a long period of time and burning up our systems. But I'm going to change this as 128 amps because that's the maximum current that I can get out of a CMC 356. And then underneath that, we've got our debounce time and our deglitch filters. And with that, we've got our debounce time of 3 milliseconds, and my deglitch time is going to be set at 0. But you can change that if you want to basically override some glitches that you may end up coming inside of your pickups for your binary inputs on it. And so I did want to go back and revisit that real quick. Once I'm okay here, again, I would say okay. And as I mentioned earlier, there is a hardware configuration. And on the hardware configuration, we can come in and specify what hardware I'm using. Typically, if I'm connected to a test set, which I'm not at this point in time, your test set would come up, and where I've got these question marks, you would actually see the serial number of your test set pop up in there. But I could change this to any different model that I want. And then if I go into my details, under details, I can select how I want my voltages and currents to actually basically be outputted from the test set. And so at the top, I am selecting a 4x300. The 4 basically just allows me to get 4 voltages out of it. And if I want to go to and off to the right, then it gives me a nice little graphical representation here of how I would connect up my voltages. But I do have the opportunity of just doing 3 at 300. I can do 1x300, and all these basically gives us some different VA capabilities. I can do 3 at 300. I can actually get up to 600 volts out of this thing at 2 different channels. And if I selected this one, it would show you how to actually connect those 2 signals up from my test set. So for this, I'm just going to use 3x300 because we only want to look at the 3-phase voltages coming out of it. Down at the bottom, with the CMC 356, I do have the capability of getting 128 amps continuous out of this for a single phase value. But typically I can get 6 channels or 6 different phases at 32 amps per channels. And this is continuous current. And so you can turn this on and you can run this for a long period of time and not have to worry about any kind of effect or anything happening here. The next 2, basically, if I've got a 356, I can specify whether I want this as channel A or I can do this as a channel B output off of my test set. I can do 3x64. 3x64 allows me to basically combine phase 1s on both channels A and B together and feed them into an input on my relay, and I can get 64 amps continuous out of this for 3-phase. And that's not a bad one to use a lot of times. And if I want to get 128 amps out of it, this is my configuration that I would use. And so 1 and 2 on both A and B are combined together to get the polarity part or that channel out for 1. And then my neutrals would be connected to 3, connected together, and also my neutrals together on both channels A and B to provide my return for my currents. And so for this example that we're talking about today, I'm just going to use 3x32 and say OK here. And once all this is good, I can hit the apply button. It's always good to hit the apply button to make sure that everything is working well with what we've got set up on that. If there's any errors or anything that's not going to work well with the test set in our software, it would spit up a little window and say, hey, you might want to look at this and fix this and make corrections there. And so with that, I would say OK. And now this takes me back into this window here. I'm going to move over to this 3rd tab right now. On this 3rd tab, pretty much I can do a search test. And on a search test, what that allows me to do is that actually allows me to put search lines in here. And so there's a couple different ways that we can actually go about it. Let's just say that I want if this to follow the angle of 75 degrees, and I could put a search in here, let's just say of maybe 11 ohms at 75 degrees. I can come in and hit add. And so now it's basically going to allow me to do a search line up to 11, and it will actually go out and search across that zone 1 to find the pickup value for me. And here again, I can select any kind of a fault type that I want. And we've also got the tabs at the bottom that's going to show up as far as this search test is concerned. One thing to keep in mind is if you're doing a search test and a shot test, they basically can't be done within the same module. here. So I've got to basically do either one or the other. And so I'm going to go back into my shot test and do a remove all. And I'm going to remove all of my stuff that I've got out there. Just to clear everything up so I can go back into my shot test. Or my search test and show you how that actually works. So here again, you can add them manually if you want. If you do a right click, I can basically come in and I should be able to put a search line in there across there. And so now if I add that, that gets added in there for me. And so you can see I can cross over it if you want. I can make that much smaller, but here I'm crossing over all 3 different zones. And I'm going to find the pickup on my different zones there. The other thing that I could do is if I wanted, I could add a sequence. And so on my sequence, I can basically specify my origin of what I want. And then I can come in and put a start angle, put an end angle in here, and then I can put some steps in here. So let's just say I wanted to do a search at let's just say 85 degrees, because that's going to be our I'm sorry, not put 12 ohms there, and I basically want to make this at 85 degrees. And now I can come in and do a start angle. And what this start angle is going to do is I can specify maybe I want to go maybe 30 degrees on the side of that. So I could start at 55 degrees. And maybe I wanted to do this or my end angle would be, let's say 30 degrees on the other side, which would be 115. And then I could add a sweep in here every 10 degrees if I'd like, or every 5 degrees or whatever. And so now this is going to create 7 search lines out there. And I'm going to say OK. And so now you can see that since I started up here at 12 ohms, that's where my starting point is. But let's just say I want to remove all those and go back in there and start at my 0 degrees. And here at the angle, it doesn't matter, but because I can put the 0. And let's just change this back to what I just did, 115 every 10 degrees. And now if I hit OK, now you can see that I've got all these lines that are going to cross over my zone 1 and search for a pickup for me. And I can do this for different sequences out there, or different fault types. You know, it just basically depends on what I want to specify, but also I can set up this search line. As I mentioned earlier, I can also come in here and, I can do a drag and drop across these and get this different lines and features that I showed you earlier. Over here, all the way to the right, is this trigger tab, which is kind of very important if we want to be able to find the pickup values on these things. And so back in the hardware configuration, you can set up your analog and your binary inputs, your binary outputs. And right now we've got a binary input set up as a trip on binary input number 1. Binary input number 2 is a start. And so we've got up to 10 different binary inputs that we can have on here, and the rest of them are not being used because we don't have them configured in my hardware configuration. So go back to my hardware configuration real quick to show you this. My binary analog inputs, all these other ones aren't being used. I can change this to be whatever I want and get any kind of a name. So basically, this is going to be binary input number 2. And what I can do is I can give it a display name of start, or if I was using it to start carrier, I could give it some kind of a common name that would mean something more to me. And then over to the right here, we can select whether we want these to be potential free contacts or whether we want these to be a wetted input. And so if I uncheck my potential free, I can specify my nominal voltage. So if I've got 120 volts, or I'm sorry, 125 volts as my nominal voltage, I could put this in here. And what this is going to do now is take 70% of 125 volts and make this as my threshold value here. And so anything above 88 volts is going to trigger a that binary input to actually close, or basically if you want to think of it assertive or deassertive, it's going to assert at that point in time, and that would stop my test that I would have running. And so here you can come through and identify all these depending upon which binary inputs that you're actually using for this configuration here. And so now you can see when I change that name for this second binary input, I've got a start carrier in there. And so on start carrier, it allows me to change this from basically a 1 to a 0 or 0 to 1. And so I can select anything from the drop down box. If I have an X in there, the X basically tells me that I really don't care what that is, and I'm not going to look at it, or I'm not going to use it. And they here. All right, and then basically this next tab here is called the settings tab. Under the settings tab, you can select how you want to use your test model. And so on your test model, you're going to specify whether you want to use a constant current or a constant voltage to run your test. And so there's a drop down box here that allows me to select whether I want a constant current, constant voltage, or I can do a constant impedance, whichever you guys typically would use for your testing. So I'm just going to say constant test current. And then you can specify your I test. Now, one thing that you'll see here is this is actually a darker color. It's kind of got a darker background to it. It's maybe a purplish looking color. And so what that means is that's actually linked to a value, but that doesn't mean that I have to use 10 amps as my maximum current. But that I test current is typically 2 times my I nominal, which is the value that I had set up in my object file under my device Rio function of it. And so there's some options that I can use here. If I right click on this, I can go to a linked XRIO file. And here again, this 5 amps here is my nominal value, which is being shown up here from the list that I've selected to use. And then I'm actually multiplying that by 2, or a factor of 2, to come up with 10 amps as the test current that I want to use. If I wanted to use something different, I could change this to just say 1.5 times my nominal current. And so that's going to give me 7.5 amps as my test current that I'm using. And so it's my constant value. If I want, I can come out here and I can do a remove link. And so if I remove the link, I can actually put in here a value that I want, and I'm no longer linked to that value that we saw earlier. So again, it's a preference on how you guys do your test and how you want to do your test. My maximum fault impedance I've got set up here as 6.9 ohms. That's phase to ground. I've got phase to phase, 3-phase. I can change these to different values. Well, these are all basically calculated on the values that we had from our setup. So you can't change any of those values here. And then if I want, I can basically limit my, put my Vmax at value here. And here again, you see that this is purple, and this is also linked back to my Rio file, and it's basically 1.2 times my nominal voltage that I've got set up. And so here I can say okay, or I can make a change here, or I can right click on it and change it to whatever value that I want. And if I want, I can allow a reduction of the eye test value above to basically meet these specifications. Under my fault inception, I've got a mode of random, but you've got a drop down box of you can either do a maximum offset, zero offset, or a fixed angle. So those are the different values that I can choose there. And if I select angle, I can come in and change my fixed angle degree if I choose. I can use a DC offset in here if I would like, and so it's going to throw in an offset value there when it runs the test. And if I want, I can add a load current. So if I'm looking at a load current, maybe I need something for a pre-fault, I can actually put that in here. And so in this case here, it's defaulted to 2.5 amps, but if you wanted to change that to a different load current for your pre-fault value, you can put that in there. And then you can also choose to hit ignore nominal characteristics if you want. So by checking that one, it'll ignore those nominal characteristics. And then down here for my search interval, I've got it set up at 200 milliohms. And so you can change your search interval. So that's what it's going to go out and search across this, the target with in our search test. But this is where I can set up some of the values for that. Over here under times, I can set up a pre-fault time if I want. On my pre-fault time, this is set up at 1 second. Sometimes a digital relay maybe needs to see a certain values on that before it actually is going to do something out there, and basically calculate everything from that. So sometimes you may need a few cycles or seconds or whatever pre-fault value in there. Then you can set up where you've got a maximum fault time on there. And so the maximum fault time here would be 6 seconds. So if something does not happen within that period of time, then it's going to kick the test into the post-fault state and come back with a non-passed value on my fault. And then the post-fault, you can actually set up any kind of post-fault that you actually have or other that you want to use out there. So in this case here, we're set up for a half a second. My time reference there can be fault inception or starting time. And here again, that just depends on what you're using for your relays. If I want, and back in my Rio setup, I can use extended zones if I want. And so if I'm using an extended zone, I would check this box here to go and use this in here as my part of the values that I've got set up. And then you can actually have this switch off at 0 crossing, which is going to turn off my current and voltages going into that. And underneath that, then you've got your search resolution. You can either do a relative or an absolute value. And so that basically is going to allow me to set up my resolution values for that one. So that was my settings tab and all the things with that. We've talked about search test and how to go about adding a search. And then the other thing would be a check test. And this check test basically allows me just to go out and do a check however I want. And so here again, I would come in, I can put my check line in. I can start out with my origin where I want it to start. And then I can put whether I want it to follow the line angle. If I want to choose what I've got set up in my distance section of my object file, or I can put some kind of another angle here. I can put my length if I choose to put in a length and some kind of an impedance value, or I can basically choose to get maybe, I don't know, 75% of my line angle. And under line angle, you have the option of either doing line angle or zone 1, zone 2, zone 3, zone 4, or all zones. So let's just say line length here. I come in and add this one. And so now I've got this angle. This line is going to go from 0, 0 all the way up to 75% of the line, which pretty much is not going to do anything in here except for get a trip on my zone 1 at this point here. So one of the things to keep in mind that if you was going to run this inside of what we call our OCC files or our template, I would separate my shot test from my search test, and I would create a separate module for each one of those, since it doesn't allow me to basically combine those together. And so I would maybe have one where I do a shot test, and here again, or another one where I would do a search test. And all this really basically depends upon how you guys run your test, or what kind of a procedure you guys do to actually commission your relays out there. This is just a tool to kind of help you get through all those things. So once I'm satisfied with everything, if I wanted to run a test, I can come up and hit my start button, and anything that I have in here, so I've got one here, I've got one out here for my search test. These basically can be all ran, and I would run my test and it would go through everything from start to finish just by clicking my start button here. If I want, I can come over and do a single test, and by clicking on a single test, I can just come out and run a single test. Or if I want, I can use my static output, and my static output is going to put in there anything that I've actually got included in my box at that point in time. So if I wanted to basically do a test on, say, some certain values, I could change this. Let's just say this is a 15 ohms, 70 degrees. And by doing a static output, it's going to actually run that test specifically just for these points that I've got in there. So you see that they become grayed out, and I can't really change these because I'm trying to run that test right now. And since I'm not connected to anything, my test set's not running at this point in time. Under my view, on my view, I can change whether I want this values or whatever to be in seconds or cycles, or primary or secondary values, or absolute or relative. Also, I can select some different views that I've got here. And what that does is show some different test views. So right now I've got test view, which is this window that we've been looking at right here. But I've also got this impedance view, which is the other one we've been looking at. But you can do a time signal view, a phasor view, or time gradient view, or you can do the report views. And all these tabs are located at the bottom. Does the same thing as you could by clicking up there in that tab. So if I wanted to look at my time signal view, this would basically show my currents and voltages as they're coming out. And then likewise, these last two things would show me that when I run the test, when the binary inputs pick up for whether a trip or a start carrier signal. If I want to look at my phasor view, I can actually look at my phasors out there. And I can look at also information that I'm going to see that the test set's going to be outputting. And so here, if I was doing a phase-to-phase value over here, this is actually going to show you my phase to neutral values that my test set's actually putting out with my magnitude of my phase angles. And it also shows it in a real and imaginary values. For voltages, for currents, this table shows it for voltages and also for currents. And it also is going to show positive and negative and zero sequence for both voltage and for current there. So if there's things that you want to look in some kind of a different format, this is where this would show up in this window here. And this is what's actually coming out of my test set. My time gradient diagram basically would show the configuration from everything that we've had set up into our templates. And then my report view pretty much would give me the values that are going to be recorded from the different tests that I'm running. And so everything is going to get recorded here, and then to be on the bottom here, it'll actually tell you whether it passed or failed. And so that's pretty much the report view. The report view is pretty, you can change the report view to be whatever you want. If you want to see more information, you can have a lot more information show up on that. If you want less information, you can basically have it show less information for your report. And so if you was to print this out, the more information you have, the more pages you're going to get spit out with the printout. But a lot of times we save these things as digital files. And it just depends on what you guys want to see as far as the report is concerned and all that. And so that's pretty much everything as far as what it would look like with the impedance and the distance module. The only difference between the distance modules is that your regular distance only does a shot test, and then your check and search ones are basically things that are associated with the advanced distance function out there. Just to kind of show you what this would look like as part of a test plan. This is a Schweitzer relay, and let's just say we're going to look at like a 421. And on a 421, it has all these test modules in here. And so some of these are using the distance function. So we've got 18 test modules in here. And so what we would have is some different modules here for my distance. And so here, this is doing a shot test. And this shot test is basically based upon all these different values for a phase to ground. And so as you can see, we're doing a phase A to ground, a phase B to ground. We can do a reach, basically phase B to ground. And so this one is doing a check test. And so on my check test, these are the two tests that we run under check. And so you can see that we've got some different tests, but we break them down by different groups so that you're not throwing everything into here as one unit, because you could run everything with basically one module if you want. But sometimes if something fails and you need to just go back and test a certain portion of it, you can actually go back and make some changes to it, and you don't have to run the whole test from start to finish. One of the other nice things, sometimes it just depends, and it just depends on your settings and things. You can import the settings into this program. And so if I would come back and let's just say I wanted to look at my object file here, which is at the top now. And if I looked at my distance protection function, what you can see now is we've already created this with some different zones, but these are going to look for a lot of different zones, and typically you may not have all these zones that you want to use. But, being an international company, we want to make sure that we try and incorporate as much information as we can into these different test plans. But based upon your settings, these would be parsed out. And so I may not have 5 or 6 or 7 different types of areas that I'm looking at. And so here we've got Mohs circles and quads, and we've also got this thing with load encroachment that's basically coming in. And so this brings a lot of different information into my test plan. And based upon what my settings are, you may or may not use all that list of things out there. And so here you can see my overall diagram. You can see my load encroachment angles here. You can see my Mohs circles. If I was doing quads, the quads would show up in here. You got forward and reverse looking zones and all kinds of different things like that associated with this specific test plan that we've got there. So that kind of pretty much concludes what I have. I will open up everything for any questions if you guys have questions. If you don't have any questions, you're free to go on. But anyhow, I appreciate you guys for participating today in this webinar. And if you have any questions, you can basically email me if you'd like. There's my information again. And so you're welcome to get a hold of me anytime that you want. So
just using OMICRON to do distance. Oh yeah. It would be interesting to see where tests have in action.
it's hopefully if you learned a few things today, and basically it'll help you out with what you want to do with all your tests. So with that, and if I don't have any questions out there, thank you
Tim,
for
I
participating. But go ahead.
Hello?
Go ahead.
Yeah, I just need to ask if I want to import a Rio file from a distance relay, how can I do that?
Okay, and what kind of a relay are you using?
Actually, I'm using a Siemens distance relay 7SD.
Okay, so going back in, let's just go in and open one of these up. And let's just find the Siemens relay. And I can pick any one of these. It doesn't really matter because the way it gets handled with everything out there is I would come into my object file here. It's always going to be that first thing in that list there. And what I would do now is come up and hit my file. And the third line down is called Import Relay Settings. Okay, don't confuse that with the import button we've got up here. So we want to import the relay settings. And then over here, a window will pop up and it'll ask us for what kind of a relay or what kind of a filter we want to use. And so for the Siemens relay, and you talked about the XRIO files, I would select XRIO on that one and I would say okay. And then it's going to open up a window where I can come in and where I actually have my XRIO file stored. So wherever you got that relay file, you could come down and select it. I don't have any XRIO files here that I could use, or I'd show you how to do it. But it's looking for the one with the .xrio extension on it. I would select that out of my list. I would hit my open button. When I hit open, what's going to happen is in this window over here, if I put select this advanced function and also select my errors, this window opens up this section at the bottom. And so it's going to come in and it's going to import all my settings, and it'll tell me that I had 200 settings imported or parameters imported. And down here at the bottom, this is going to show all my parameters that were imported here in this list. and then it would basically tell me where it's located, what the description is on it, and all that good information. And it should come in and tell me that it imported like 200. So instead of this being 0, it would be 200 parameters imported. If I had any warnings associated with that or any errors, I would want to make sure that I would go back and kind of check these errors and warnings out and make sure that there's nothing major affecting any of my relay settings there. And sometimes it's not, sometimes it is. But it's also going to show up here under this type. The type will come in and say whether it was a warning or an error. And by just clicking on this line, any one of the lines that are here, it'll jump you into where that setting is on the screen. And you can go in there and look at the values and change them and fix them if you want to. So I don't know. Does that help? I mean, I really don't have anything that I could show to import.
Yeah, it's okay. It's okay. And just I need to ask one other question. The file you showed us before for cell 421, in that file you have like different options available, like short test, search test, and check test. Yeah.
Correct.
And if I just want to run only one test, so say I should just click that test, double click that test, and just I can start that test, or I had to do something else to.
There's a couple. You could basically come in here and open this up so if I double click and open it up, I could run it inside there underneath that
Yeah.
module. And I got to basically make sure I get a module opened up here. So let's just say wiring test. Okay. This probably isn't a good one, but I come up and just hit start, and then it would run my test, and then I would have to, then it would basically tell me whether it passed or failed. So I could run an individual that way, or the other
Yeah.
way of doing it would be to come down and I could click this start button at the top here, and since I've got this highlighted, it would run that specific test for me and not run everything else. The double arrows here, the double triangles, is going to run everything in that program from start to finish. Let's say that we ran these first 5 or 6 tests up here, and then we stopped it because we wanted to go to lunch. If I come back and hit start, continue again, it picks up where you left off, and it runs your test for you and completes the rest of them. So this start, continue all does everything. This start, continue with a single triangle basically allows you just to do one test at a time.
Yeah. Okay.
And then just say that we ran this whole thing and we wanted to go back and redo one because maybe one of these had failed. I would come in and click on this. The clear button here that would be black, and I could click on that and I would clear that one out and I could rerun that test again, and it would just run that specific test for me. And then also keep in mind that when you're running these tests, anything with a checkbox would run. Anything that does not have a checkbox, or if I unchecked it, that test would not run if I was going to do everything from start to finish. So does that help you out?
Yeah, and during when we are drawing that characteristic, you selected tripping and starting zone. So what is the difference between if I select tripping zone, so this is like a kind of tripping contact, or what does it mean? Like, what is the difference between starting and tripping zone?
Some relays have a starting function that's associated with it. So basically everything needs to, the starting, so I'm from the US, and so I don't know where you're from, and maybe I'm assuming you're from somewhere else, or you're not from the US, or I don't know where you're, but different manufacturers have different ways of how they do it. And so the starting function was something that I've noticed has been kind of used in like Siemens and a lot of those types of relays. So they're, whereas you use like a SEL doesn't, and in America, we don't use any of the starting functions or anything like that one. It's just a tripping zone. So there
it
are
means like if I just want to do like a zone reaches test, I can select all zone as tripping zones, and I can select check a search test, and I can do my zone reaches.
Yes, exactly. And it would go through and check those for you, yes.
Yeah. Okay.
But very good
And
questions.
secondly, you are saying that that video is recorded, and if I need to see that video again, so how I can?
How this should work is you should get, I think, a email from us saying that you were here, and I have a link to that recording. That's how it's
Okay.
supposed to work. But let me show you one other thing too here that you bring up a good point is under Test Universe off to the right, there's this button called Tutorials. And
Yeah.
Tutorials is a very nice feature that we have now with Test Universe 3. This is a list of all the tutorials that we have out there based upon all the different modules that we've got. So we were talking about advanced distance modules. So right here we've got an advanced distance module part 1, 2, 3, and 4. These are also excellent places to go to find information on stuff that I had told you about. And so you can use those as reviews too. And so they're only like maybe 3 to 5 minutes long or 10 minutes long at the most. So it's really a nice place to go out and review some different things.
Yeah.
Okay.
Okay.
Anybody else?
Nothing,
No, it's good. Thanks.
All right, guys. Well, I appreciate your participating today. Have a good weekend.
Sir,
Work
I
safe
have a
out there.
question.
Sure. Go ahead.
Yeah, thank you. My first question is that there are three tests available for advanced distance: the check test, surge test, and short test. As far as I
Right.
know, short test is for timing, surge test is for reach test. What does it mean by check test?
The check test is you're just doing a check out there. It's just, I know it doesn't make a lot of sense. It's just, I mean, me personally, like you're saying, I would probably either do a shot test or I would do a search test. I probably wouldn't use the check test that much in any test that I would do because it's just, you're just doing a quick check out there. And I'm not sure that
Okay.
I'm giving you a good answer here, but
Okay.
I
Okay.
can always maybe get you a better answer and send that to you if you want. So.
Okay, I'll contact you later. My next question is that if I wanna add the load encroachment characteristics in the tripping zone, how can I?
How can you do that one?
Yeah, yani some
Okay.
part of the tripping zone, it is covered in the load encroachment. I want to inform the test set that this area will not trip. So in my report, it should be like that. How can I add the load characteristics inside the tripping zone?
Okay, let me open up that one again that I showed you earlier, which was the Schweitzer one.
I'm asking without PTL, without PTL.
No, I understand that, but I was just going to use this as an example and go into that module and show you what it looks like on the
Okay.
setup. Okay, so if I come back into here, which is my object file, which is the object file you're going to have on all of them, under my distance protection, under my zone settings, down here at the bottom, this is my load encroachment for positive. And so if I edit it, I'm just, so this is what it looks like here. And so what happens is I'm going to put a Cartesian line in here with some values. So you got a 30-degree angle, which is this one here. I'm also going to put some kind of an arc in here. And this arc basically talks about my direction. And on my arc, I'm going to start it at minus 30 degrees and go to plus 30 degrees. So that's going to be from here to here. And so you also have that reach value that's associated with it, or the radius. So in this case here, it's 9.2. That's also a setting that's in your relay. And so that's how you would set this arc. So basically you're creating a circle, and then we're coming through and chopping it with these two different angles. And then the other one basically is going to be my 30 degrees and a positive one here. And so by starting this point, doing my arc, and then ending with this one, what it allows me to do is get everything underneath of this, those three sections as my load encroachment area. So that's how we set these up, is by selecting these three different things.
Okay, sir. We are defining a tripping zone separately and a load encroachment zone separately. When I will test the reach characteristics, if the encroachment characteristics are inside the tripping zone, how it will segregate?
So now if I come back, and this is probably not a good example, but you can see that right here is we've got this little section here, is inside of basically my zone, one of my zones there. So you would have to basically, let's see, I know your question here. So if something was to trip right here in this little section on this zone, how do you basically keep it from not tripping for that portion, correct?
Yeah.
And so I would come in and I would set up some tests. So when I'm inside of it, I would basically, you could do a shot test where I could put a shot here, a shot inside, and basically see where it's all tripping at. And that's how I would go about basically setting up my test in that case here. Okay.
Okay. My next question is that if I'm setting both the tolerance values absolute and relative, which one will be valid in the report?
So with my settings there, it basically will use the larger of the two.
Okay, larger of the
Between
two.
them. Yes, yes. Now, if you want, you can turn one or the other one off, and then basically you can have it specifically do whatever you want, whether it's absolute or relative. But sometimes, a lot of times people will put both of those in there, and it just takes the larger of the two.
Okay, okay. If both are selected, larger will come in action.
Yes, yes.
Okay, thank you. The last question, there is a setting in the device that is debounce and delay time. What is this, sir?
What is that?
Yes, what is the purpose? If we are changing from the default value, what will be the effect on the test?
Okay, let me come back in here. If you hit on this help screen, on this help screen, this is one way of going through and looking for help. But down here is these debounce and deglitch filters. And so the debounce, or the deglitch, when basically if there's a glitch or something going on here, you don't want it to basically do anything. So if this is my signal here, and I've got my deglitch time on, this is what it's going to actually look. So if any little glitches that are showing up here that are outside of this, it's not going to pick up for it. Likewise on debounce time, debounce, contacts are going to be bouncing out there sometimes, especially in electromechanical relays. And so if this contact is bouncing around here, basically we want to set a time that we don't want it to, where we want it to distinguish whether it's a good trip or a bad trip, or it's just bouncing around out there. So this is basically some explanations on those two different signals and how you can change them on there. I mean, most of the time it may not be an issue, but sometimes you may want to change them. So,
Thank you. Thank you very much.
right. Anybody else?
No, sir.
Okay. You guys have a.
Thank you.
All right.
Thank you
Have a
very
good
much.
one. Thanks. Bye.
Thanks a
Bye.
lot.